Hello friends, welcome back to my channel. Today I would like to share with you some of the reversible reactions and equilibrium. What are reversible reactions? In some chemical reactions, the products of the reaction can react together to produce the original reactants. These reactions are called reversible reactions and can be represented in the following way. You can see reversible arrow here, A plus B, reversible arrow, C plus D. The symbol reversible has two half arrowheads, one pointing in each direction. It's used in equations that show reversible reactions. The forward reaction is the one that goes to the right, and the backward reaction is the one that goes to the left. Example is been shown here, the reaction for the Haber's process, which is the production of ammonia from hydrogen and nitrogen, can be represented using the reversible arrow. Another example which involves hydrated salts and anhydrous salts. Hydrated salts are salts that contain water of crystallization, which affects their molecular shape and color. Blue copper sulfate is described as hydrated. The copper ions in its crystal lattice structure are surrounded by water molecules. This water is driven off when blue hydrated copper sulfate is heated, leaving white anhydrous copper sulfate, and the reaction is reversible. CuSO4.5H2O gives you CuSO4 plus water. Similarly, when hydrated cobalt-2 chloride is heated, it loses its water of crystallization and turns into blue anhydrous cobalt-2 chloride. When anhydrous blue cobalt-2 chloride crystals are added to water, they turn pink and the reaction is reversible. COCl2.6H2O gives COCl2 plus 6H2O. What do you mean by dynamic equilibrium? When a reversible reaction happens in a closed container, it reaches a dynamic equilibrium. At equilibrium, the forward and backward reactions are still happening. The forward and backward reactions have the same rate of reaction. The concentrations of all the reacting substances remain constant. For a reversible reaction, the position of equilibrium is affected by changing temperature, changing pressure, changing concentration, using a catalyst. And this can be done more clearly by Le Chatelier's principle. Le Chatelier's principle states that when a change is made to the conditions of a system at equilibrium, the system automatically moves to oppose the change. Here, as you can see, a reaction A plus 2B reversible gives C plus D. When concentration of reactant increases, product formation is favored. When the pressure is increasing, side with fewer gas molecules is favored. As the temperature increases, endothermic reaction is favored. And when the product concentration increases, reactant formation is favored. Side with more gas molecules is favored when you decrease the pressure. And when you decrease the temperature, exothermic reaction is favored. So let's see one by one. Changing the temperature. In a reversible reaction, if the reaction is exothermic in one direction, it is endothermic in the other direction. If the temperature is increased, the equilibrium position moves in the direction of the endothermic process. For example, in the Haber process, as you can see, nitrogen plus hydrogen gives 2NH3. Forward reaction is exothermic. Therefore, if the temperature is increased, the equilibrium position moves in the endothermic direction to reduce the temperature. This means that less ammonia will be produced. And when you change the pressure, if the pressure is increased in a reaction involving gases, the equilibrium position moves in the direction of the fewest molecules of gas to reduce the pressure. N2 plus 3H2 gives 2NH3. If the pressure is increased, the equilibrium position moves to the right. And when you change the concentration of a reactant, if it's increased, the equilibrium position moves in the direction away from its reactant. And so more of the products are produced on the right. If one of the products is removed from a reaction, then the position of equilibrium moves to the right to make more of that product. For example, iron 3 ions react with thiocyanate ions in a reversible reaction, as you can see here. The equilibrium position will move to the right in the direction away from Fe3 plus in the equation. And what will be the effect of catalyst on equilibrium position? The presence of a catalyst does not affect the position of equilibrium, but it increases the rate at which the equilibrium is reached. The catalyst increases the rate of both forward and backward reactions by the same amount. Here comes the Haber's process to manufacture ammonia. In the process, nitrogen from the air and hydrogen from natural gas reacts to form ammonia, and the reaction is reversible. The production of ammonia is exothermic. This is a flow chart for the Haber process. Nitrogen from the air and hydrogen from natural gas react in 1:3 ratio by volume under 400 to 450 degrees Celsius temperature and 200 atmosphere pressure and iron catalyst. What would be the effect of temperature in Haber's process? The forward reaction, which is the production of ammonia, is exothermic. Hence, lowering the temperature will favor ammonia production. However, the rate at which the ammonia produced will be so slow as to be uneconomical. In practice, a compromise or optimum temperature is used to produce enough ammonia at an acceptable rate. Modern plants use temperatures of about 450 degrees Celsius. What would be the effect of pressure in Haber's process? There are 4 molecules on the left-hand side of the equation, but only 2 on the right. The position of equilibrium can be moved to the right by using the high pressure. It should be noted, however, that the high pressure used is very expensive and is a major safety concern. So 200 atmosphere is a compromise pressure between a lower yield of products being made safely and economically. The effect of catalyst in Haber process. A catalyst of iron is used to speed up the reaction. The catalyst has no effect whatsoever on the position of the equilibrium. Adding a catalyst doesn't produce any greater percentage of ammonia in the equilibrium mixture. It only functions to speed up the reaction. The next topic is about sulfur and sulfuric acid. Sulfur is found in its elemental state underground in the USA, Mexico, and Poland. It's also a byproduct from the removal of sulfur from petroleum and natural gas. Sulfur can also be obtained from sulfide ores. The main use of sulfur is in making sulfuric acid, which is a very important chemical used in many industries. Sulfur dioxide can be made by burning sulfur in air. This is the method used in the first stage of manufacture of sulfuric acid. Sulfur dioxide is used as a bleach in the manufacture of wood pulp for paper and as a preservative for foods and drinks by killing bacteria. Sulfides are often added to foods, and these release sulfur dioxide in acidic conditions. Here comes the manufacturing process of sulfuric acid, which is the contact process. The raw materials required for this process are sulfur, air, and water. Stage 1, making sulfur dioxide. Sulfur is burnt in air to make sulfur dioxide. This is not a reversible reaction. Stage 2 is the important stage, which is making sulfur trioxide. Sulfur dioxide reacts with more oxygen to make sulfur trioxide. This reaction is reversible. The conditions needed for it are a catalyst of vanadium 5 oxide V2O5, temperature around 450 degrees Celsius, and a pressure of approximately 2 atmospheres. The increased pressure favors the formation of SO3, but if the pressure is too high, the risk of explosion is too great, given that SO3 is a highly acidic gas. And the stage 3 is making sulfuric acid. Once the stage 2 is completed, sulfur trioxide is absorbed into a solution of 98% sulfuric acid to produce a thick liquid called oleum. SO3 plus H2SO4 gives H2S2O7, which is oleum. It's not absorbed into water because a fine mist of sulfuric acid would be produced, and this would be difficult to condense, and it's also highly dangerous. So after oleum, water is then added to the oleum to form sulfuric acid again. H2S2O7 plus H2O gives 2 H2SO4. What are the properties of sulfuric acid? It's a strong dibasic acid because it contains 2 hydrogen atoms which can be replaced by a metal. It reacts in a similar way to other acids with metal carbonates, metal oxides, metal hydroxides, and ammonia and metals. Example is shown here. Zinc oxide plus sulfuric acid gives zinc sulfate plus water. Sodium carbonate plus sulfuric acid gives sodium sulfate plus carbon dioxide plus water. Concentrated sulfuric acid is corrosive and a powerful oxidizing agent. Concentrated sulfuric acid is also a very powerful dehydrating agent and is very good at removing water from other substances. What are the uses of sulfuric acid? In dilute solution, it's used as a catalyst in many organic reactions and to clean the surface of metals. Concentrated sulfuric acid is used in car batteries, making fertilizers, soaps, and detergents. It's also used to make acid drain cleaners and in the production of paints and dyes. So that's all from me. Thank you so much for watching this.